In question 3, the diagram shows triangle ABC, which is right angled at A. Angle ABC is equals to 1 upon 5 pi radians and AC equals to 8. The point D and E lie on BC and BA respectively. The sector ADE is part of a circle with center A and is such that BDC is a tangent to the arc DE at D. So in part 1, we have to find the length of AD. Now to find the length of AD, we know that this angle is 1 upon 5 pi. This is 90 or pi upon 2. So to find angle ACB first, so ACB will be equals to, so as this is pi upon 2, so the sum of these two will also be pi upon 2. So we can write that angle ACB will be pi upon 2 minus pi upon 5. Taking the LCM, which will be 10. So this will become 10 is equals to 5 pi minus 2 pi. So this angle will be 3 pi upon 10. Once we have this angle as 3 pi upon 10, the angle ACD or ACB, we can use opposite over hypotenuse, which is sine. So sine of 3 pi upon 10 will be equals to AD divided by the hypotenuse, which is 8. So AD will be equals to 8 multiplied by sine of 3 pi upon 10. And we'll make sure to keep our calculators in radian mode. So sine of 3 pi divided by 10 and then multiplying it by 8, this will become 6.472. So the length of AD is 6.4721 centimeters. And as we have to give our answer to 3 significant figures, the final answer will be 6.47 centimeters. In part 2, we have to find the area of the shaded region. Now, the shaded region basically consists of the sector AED and the triangle ADC. Now, to find the area of the sector, we apply the formula half r squared theta. So for that, we will need this angle, and the radius will be the length of AD, which we already know, which is 6.47. So as this angle was 3 pi upon 10 in the previous part, first we can find this angle. So to find angle DAC in the first step, so angle DAC will be is equals to pi upon 2 minus 3 pi upon 10. Taking the LCM, that will become 5 pi minus 3 pi upon 10. So that will be equals to 2 pi upon 10 or pi upon 5. As this angle is pi upon 5, we know that as this complete angle was pi upon 2, so angle BAD will be equals to, so BAD will be pi upon 2 minus pi upon 5. Subtracting this, we'll again get the LCM as 10. So this will become, so multiplying this by 5 and multiplying this by 2, we'll get 5 pi minus 2 pi, which is equals to 3 pi upon 10. So now finding the area of the sector, which is half r squared theta. So area of sector will be is equals to, the formula is 1 upon 2 r squared theta. So we'll get 1 upon 2 into r squared. R was 6.472. We'll use the complete value whole squared multiplied by the angle, which is 3 pi upon 10. So substituting this in the calculator, we'll get 6.472. So 6.472 multiplied by 3 pi divided by 10. And we'll have to whole square 6.472 first. So 6.472 whole squared multiplied by, so this is 3 pi multiplied by 10 and then dividing it by 2. So just a correction, 3 pi divided by 10 multiplied by 6.47 whole squared and then dividing this by 2. This will be 19.726 centimeter squared. And now finding the area of the triangle. So the area of triangle will be, we'll use the formula half AB sine C. We know that the two lengths are 6.47, the length of AD and AC, which is 8. So the two lengths will be half into 6.47 into 8 into sine of this angle DAC, which we found was pi upon 5. So this will become sine of pi upon 5. Now finding sine of pi upon 5, so this will become sine of pi divided by 5 multiplied by 8 multiplied by 6.47 and then dividing it by 2. This will be 15.212118, and the total area of the shaded region will now be, so the total area will be is equals to 19.72 plus 15.2118. So adding 19.72, this will become 34.93. centimeters squared. And as we have to give our answer to three significant figures, so the final answer will be 34.9 centimeters squared.